All right, so what if the coefficients are not the same? So when we have problems like this, so they're both equations are in standard form here. So we see the x's and the y's are on the same side of the equation. So we still want to maybe use this elimination method, but you'll notice the x coefficients are not the same and the y coefficients are not the same. So there can't be any elimination that happens either by adding or subtracting yet. So what we do on a problem like this is we decide whether we would like to still work with the x's or the y's, and we want to get them so that the coefficients are the same. So either the x's make them the same or the y's make them the same. So if you multiply one of the equations, or sometimes both of the equations, by a number, you get a new equation that will be equivalent. So like when we have, let's say we had the fraction 1/2. Well, if I multiply both the top and the bottom of this fraction by the same number, if I multiply the top and bottom by 2, I get 2/4. Now, you know, if you're eating some pie, if you take half of the pie, that is the same thing as cutting the pie into 4 equal slices and taking 2/4 of the pie. So 1/2 and 2/4 are equal to each other. They look different, but they are equal. Same thing is true for these equations, and we've kind of done this already when we multiply by -1. But I can take and multiply one of the equations or both of the equations by a number and create a new equation that is equivalent. They'll have the same solutions. So what I'm going to do is on this first one is I'm going to notice the y's have a positive and a negative. I kind of like that. Positives and negatives work out really nicely when we're doing the elimination method, because that means, if you recall, that we can add the equations together when we have a positive and a negative. So what I really would like is for this to be a 3, because then I have 3y and a minus 3y, and I could add them together to eliminate. Well, I can do that by taking this whole equation and multiplying it by 3. All right? I have to multiply everything by 3 to make it an equivalent equation, like the 1/2 and 2/4 thing. I can't just multiply one of the variables by 3. I have to multiply everything by 3. So basically, I do a little distributive property here. So I chose the variable I'm going to eliminate. I'm going to eliminate the y's. We're going to use the distributive property to change the equation so the coefficients match up. So 3 times 4x is 12x. 3 times 3y is a positive 3y. 3 times 11 is 33. Now on this particular one, I don't have to change the second one at all because that's going to line up nicely now, but let's just rewrite it so that they're stacked up with each other here. And now I know that we can add those equations together to eliminate the y's, because the y's now have the same coefficient, a positive and a negative of the same coefficient. So when I have that, we know that we can add them together, and that means that we're going to add each pair together. Right? So we're going to take and we're going to add these, and we're going to add these, and we're going to add these. All right, so 12x plus 2x is 14x. 3y plus negative 3y is 0. Now, we can keep writing 0 in here if we want, but really we know that those y's just disappear. And so maybe you want to cross it off. If you want to write the 0 there, that's fine. 14x equals, okay, so 33 plus 9 is 42. So I have 14x equals 42. Let's just go ahead and solve that now. 14x equals 42. That means x is equal to 42 divided by 14, which you might know is 3. So half of our solution is 3. That's the x value of our intersection point for our solution. Now let's go ahead and get the y value. Once again, go back up to the equations, whichever one you think is easier to work with. I don't know. I mean, the first one's got all positive numbers, but they're kind of bigger positive numbers. I might just take the second one. You can take the first one if you want, but I might just take that second one because I think the smaller numbers here might work out. You know what? No, I'm gonna take the first one. All right. I've told you guys to stick with positive numbers as much as possible, so I think we're gonna stick with the first one. So I'm gonna rewrite that one. 12x plus 3y equals 33. All right, so notice now we have the x part first. So that means that in order to solve this, we got to plug that 3 in for the x value. And so now we've got 12 times 3 plus 3y equals 33. 12 times 3 is 36, so 36 plus 3y equals 33. I guess I'm going through my solving steps here, so I'm going to do a little line down. Subtracting 36 from both sides, I get 3y equals 33 minus 36 would be negative 3. So 3 times what equals negative 3? 3 times negative 1 equals negative 3, right? If we did our last step here, dividing both sides by 3, negative 3 divided by 3 is going to be negative 1. So negative 1 will be the y value for our solution. So now we have the entire solution. If we graphed these 2 points using Desmos, or if we graphed it by hand, I suppose, then we would have those 2 lines cross at the point 3, negative 1. All right, final example here. Mr. Swigum is raising money to buy himself some next level hilarious dad joke books. I've got a few of those, but I could always use some new ones. He decides to bake his world-famous chocolate chunk and sugar cookies and sell them at conferences for $7 a dozen for the chocolate chunk and $5 a dozen for the sugar. Those are my favorite 2 cookies, by the way. He would like to sell 16 dozen cookies and would like to earn $100. All right, so, maybe I can get a bunch of new dad joke books for $100. That sounds like a good deal. Write 2 equations, one for how many dozen cookies you will sell and one for the amount of money. So let's take a look at the money equation here maybe first. So money equation, we got $7 a dozen chocolate chunk. We got $5 a dozen sugar. I'm going to total up to $100. So, all right, let's write that equation. So we've got $7 per dozen of chocolate chunk. So let's call C equals chocolate chunk. And I'm going to then add $5 per dozen of sugar cookies. So let's say S is sugar cookies. So $5 per dozen of sugar cookies, and then total of $100. Okay. The other one is related to the total amount of cookies. So the total amount of cookies is 16 dozen cookies. So between the chocolate chunk and the sugar cookies, 16 dozen. So that just means that my chocolate chunk dozen plus my sugar cookie dozen have to total up to 16 dozen. All right, C stands for chocolate chunk dozens, and S stands for sugar cookie dozens. All right, so let's look at this now. Notice that our coefficients are not the same, okay? But we can get the coefficients to be the same on either the C's or the S's by multiplying. So let's multiply that second equation, because I think that's what's going to be easier, right? And you have to decide, do you want to eliminate the C's? Do you want to eliminate the S's? We're going to have to choose one, and I'm going to choose one. I am just going to choose the C's. So I'm going to choose the C's, and I am going to therefore want to make sure that this is a negative 7C here, so that when we can add them together, that we're going to get the C's to be eliminated. And so I'm going to multiply the whole equation by negative 7. All right, so when we do that, that second equation will become negative 7C. So I'm multiplying that by negative 7 minus 7S. So that gets multiplied by negative 7 also. Instead of plus a negative 7S, I'm just going to say minus 7S. And then negative 7 times 16. All right, so maybe punch that into your calculator. Negative 7 times 16 is going to be a negative 112. And we're going to do that thing where we're just going to rewrite that first equations just exactly as they are, because we don't have to change those equations. And now we'll notice that, once again, our coefficients are the same. They're opposite in sign, which is what we really like a lot of, which means that we can add these equations together in order for the elimination to happen. Okay? So if we add these equations together, now the 7 plus negative 7 is 0. 5 plus negative 7 is a negative 2s. And then, oops, I noticed over here, this should be 100. I wrote 10 there. I don't know why that extra 0 didn't appear. So that should be 100 plus negative 112, which is going to be negative 12. So negative 6 times what equals negative 12? Negative 6 times, negative 2 times what equals negative 12? Negative 2 times negative 6 equals negative 12. So let's go ahead and divide both sides by negative 2. I think I've been making videos for too long here. I'm getting a little tongue-tied. So negative 12 divided by negative 2 is positive 6. Okay? So I know my sugar cookies are going to be positive, or I know I'm going to have 6 dozen. So if you just think logically about that, how many dozen will we have left? Well, if we think about the fact that we have a total of 16 dozen, then 10 plus 6 would be 16, right? So if we took this equation right here, C plus S equals 16, and now I know that my S right here is 6. That means we have C plus 6 equals 16. And again, this is something that we're probably able to do in our head without doing the algebra here, but what plus 6 equals 16? 10 plus 6 equals 16, right? If we're going to undo the 6 right here, we get C is equal to 10. All right. So in this case, since I put the C's first and the S's second, let's think about that as 10 and then 6. For our solution, so kind of like our X and our Y, 10, 6 is going to be the combination that adds up to 16 dozen, but also gets us that $100 for the dad joke book. So let's just write what that means then. So since the C related to 10, all right, so that was 10. Actually, let's use the same color here. So 10 dozen chocolate chunk cookies, and the S right here was the sugar cookies, and 6 dozen sugar cookies would solve this system for 100 total dollars. And the other thing is we needed 16 dozen total cookies. And that is our solution, and that is it for our work with the elimination method notes.